Hi, third graders. Hope everybody's having a good day. I know my boys and I were ready to get outside a little bit this morning, so we ran around the block a couple times, and that really got our energy going so we could get our work done today. So Patrick is ready to go, and we're going to actually do a series of multiplication problems today just to get our multiplication brains going. So we're going to start with just some 1 digit by 1 digit, some of your basic facts, bless you, and then work up to some more reasoning with some other problems. So let's go ahead and just start with this basic fact here. A lot of us probably feel pretty comfortable with this one. What is this one, Patrick?
25.
25. And if we're not sure what 5 times 5 is, what's a strategy we might use to figure out what 5 times 5 is?
So you could do 5 times 3 is 15, and then you just add 10.
Okay, so you could break it up into 5 times 3 equals 15, and 5 times 2 equals 10, and then add them up. Okay. I was thinking you could just count by 5s, 5 times, right? So 5, 10, 15, 20, 25. Different ways that we could find that product if we're not sure about it. Okay, so if we're familiar with 5 times 5, this is another one we're probably very familiar with. What would that one be?
50.
50. How do we know that one's 50?
Because, I just know it.
You just know that one? How do we know it, though? If we weren't sure, if we didn't know it, how would we find it out?
You can count by 10s 5 times.
Okay, so do that for me.
10, 20, 30, 40, 50.
Okay. All right, so we've been counting by 10s for a long time since our younger grades, so we hopefully feel comfortable going 10, 20, 30, 40, 50. So we're feeling pretty good about that one as well. So now, I'm going to leave that one up actually. If we know 5 times 10 is 50, let's see if we can figure out what 5 times 30 is going to be equal to. And what's your strategy for that?
150.
All right, Patrick says 150. I agree with him. Think about whether you agree or not. And then, Patrick, why don't you explain your strategy there?
5 times 3 is 15, and then you add a 0.
Okay, so we're breaking up our... So 5 times 3, he's saying that if he knows 5 times 3 is 15, 5 times 30 is just adding on that extra place value to make it 150. For me, I was thinking, well, if I know 5 times 10 equals 50, I know that this is going to be 3 times that amount, right? So 10, 20, 30, that's 3 times what that should be. So I was thinking that 5 times 30 would be equal to 3 of these products. So 50, 100, 150. I just took that 5 times 10 and added it together 3 times to also get 150. Some of you might also decide to count by 30s. 30, 60, 90, 120, 150. You could count by 5s, but that would be a lot to keep track of, wouldn't it? But that is another strategy as well.
5, 10, 15, 20, 20.
So if we know that 5 times 10 is 50 and 5 times 30 is 150, this is the challenge. What might 5 times 29 be? I know this isn't one of our basic facts that you guys have been working on, but again, we're just trying to think mentally, see if we can figure out some of these problems using some various strategies. So if I were to show you that by itself, I know a lot of you might say, oh, I don't know how to do 5 times 29. But based on what we've talked about today, could anybody think of a strategy you might use to solve 5 times 29? Patrick thinks he knows. All right, I think I'm ready. All right, Patrick, what did you do?
First I did 5 times 20 is 100.
Okay.
And then I did 5 times 9 is 45. And then 100 plus 45 is 145.
Okay, very good. Thank you. So he broke his 29 into 20 plus 9. He used that distributive property, 5 times 20, 5 times 9, and went ahead and added those two products together to get to 145. What I was thinking is I would actually use my knowledge of 5 times 30 to help me out. So 5 times 30 gave me 150 as my product.
Minus 5.
Then since I'm just doing 5 times 29, exactly, I just need to take away one group of 5. So if I took 150 and subtracted 5, I'd be left with 145, which was the same as Patrick.
That's how I figured at the end.
All right. Again, hopefully you guys have a chance to share your strategies with someone around you. Hope you're enjoying the number talks. See you later.
Lo que vamos a hacer en este video es pensar en diferentes formas de representar la multiplicación, especialmente conectado a las nociones de conteo a saltos y la recta numérica. Entonces, si tuviéramos que pensar en lo que significa 4 por 2, ya lo hemos visto en otros videos. Podrías ver esto como 4 grupos de 2, de modo que podríamos tener 4 grupos. Un grupo, 2 grupos, 3 grupos y 4 grupos. Y cada uno de ellos tiene 2 cosas. Puse 2 pequeños círculos aquí. Así que tienes 2 aquí, tienes 2 aquí y tienes 2 allí. Y también puedes ver eso como 4-2 o 4-2 sumados. De modo que podríamos verlo como 2 más 2 más 2 más 2. Y eso por supuesto va a ser 2 más 2, 4, 4 más 2 son 6, 6 más 2 son 8. Vemos que por aquí incluso podríamos contar salteado. 2, 4, 6, 8. 4 por 2 es igual a 8. También podemos pensar en eso en una recta numérica, así que voy a poner aquí una recta numérica. Y podríamos imaginarnos 4 por 2, ¿de acuerdo? Entonces esto es 1 por 2, 2 por 2, 3 por 2 y 4 por 2. De modo que empezamos en 0 e hicimos 4 saltos de 2 a lo largo de la recta numérica para terminar en 8. Pasamos de 0 a 2, 4, 6, 8. Simplemente saltamos contando en 2 hasta llegar a 8. Si tuviera que hacer una pregunta similar, déjenme dibujar una pequeña serie de saltos y quiero que lo piensen de otra manera. ¿Qué multiplicación representa esto? Digamos que comienzo aquí y luego voy a saltar aquí, luego aquí. Estoy haciendo saltos iguales cada vez. Entonces voy aquí, luego aquí y aquí. ¿Qué representa eso si usamos el mismo tipo de ideas? Bueno, fui de 0 a 4, 8, 12, 16, 20. Salté contando de 4 en 4. Así que puedes imaginar que probablemente esto es algo multiplicado por 4. Ahora, ¿cuántos saltos hice? Hice 1, 2, 3, 4, 5. Así que esto es 5 por 4. Y podemos ver que terminamos en 20. También podríamos ver que esto es lo mismo que 5 cuatros, o 4 más 4 más 4 más 4 más 4. Y eso se ve aquí. Estamos empezando en 0, estamos agregando 4, luego otros 4, luego otros 4, otros 4 y otros 4. Tenemos 5 cuatros aquí. Vamos a hacer uno más. De modo que voy a poner una recta numérica por aquí y pensaré lo que significa decir 7 por 3. Bueno, podríamos ver esto como 7 saltos de 3 comenzando en 0. 7 saltos iguales. Así que 1, 2, 3, 4, 5, 6 y 7. Terminamos en 21. Es igual a 21. También puedes ver esto cuando hacemos 7 grupos de 3 y los sumamos. Y también podrías verlo como un conteo a saltos. Pasaste de 0 a 3, 6, 9, 12, 15, 18 y 21. Ahora solo por interés, y si fuéramos al revés, y si tuviéramos que dar 3 saltos de 7, ¿cómo sería eso? Bueno, comenzaríamos aquí y entonces daríamos nuestro primer salto de 7 hasta acá, llegamos a 7. Luego si damos otro salto de 7, llegamos a 14 y luego si damos otro salto de 7, llegamos a 21. Interesante. Al menos para esta situación, si tomamos 7 saltos de 3 o 3 saltos de 7, llegamos al mismo valor exacto. Te invito a pensar si ese será el caso siempre. Los veo en otro video.